Yes, students, today we are talking about, or I want to talk about preparation of hydrogen sulphide. And this is a simple setup showing how hydrogen sulphide is prepared in the laboratory. So, hydrogen sulphide gas, you should first know that this gas is poisonous, so when collecting it, you should be very careful. Now, this gas is prepared by the reaction of metals, a metal sulfide such as this iron sulfide and a dilute acid. So in this case we are going to use iron sulfide and dilute HCl. The reaction of the two is going to give us hydrogen sulfide. Then here we have the source of heat. Then we have water. Then the method of collection. I think the things that you need to take note of in this setup, the function of this water, why is it that this gas is collected by this method? That is a Form 1 question that you need to know, or that I know you know it. So the function of water is used to remove the traces of hydrogen chloride. The traces of hydrogen chloride, when the two gases react, you have some traces of hydrogen chloride that is going to move upward towards this side. When it reaches in this water, those traces are going to be removed. Then the equation is just a normal thing, a common thing that you need to know. So we have hydrogen, not hydrogen sulfide. We have iron 2 sulfide plus HCl. 2 sulfide plus HCl to give us hydrogen sulfide plus what? We have plus and 2 chloride. That is the equation. The equation that is going to take place at this particular point. And sulfide plus HCl to form hydrogen sulfide plus hydrogen chloride. Then this gas can also be collected over warm water. Another method of collection of this gas, you can remove this setup. Then at this point you put a water bath, a beehive, then you collect it over warm water. The water must be warm, not cold water. It should be collected over warm water. Now let's move very fast. Let's look at some of the properties of hydrogen sulfide. Let's start with the physical property. The physical property, I'm just going to highlight them, but the chemical property, that's where I'm going to focus on. So it has a strong repulsive odor, smell of a rotten egg. That is its unique characteristic. It has an odor smell of a rotten egg. Then it's a colorless gas. That's just common. Then slightly denser than air, therefore collected by that method, which is downward delivery or upward displacement of air. Then fairly soluble in cold water, forming a weak acidic solution. When you use that method of water collection, the method of over water collection, and you are using cold water, it is going to dissolve in it to form a weak acidic solution. Then now let's base on the chemical properties. That's where most of the question come from. The chemical properties. Chemical properties. Chemical properties. So, chemical property number 1, we have hydrogen sulfide. It acts as a reducing agent. It acts as a reducing agent. So this reduction or reducing property, it acts as a reducing agent. So when yellow iron 3 chloride solution is always reduced to green iron 2 chloride solution when you react that iron 3 chloride with hydrogen sulfide. This is an equation to verify what I'm talking about. Reducing agent. This is an equation. We are saying that when iron 3 chloride, when iron 3 chloride we have said that chemical properties of hydrogen sulfide. When iron 3 chloride reacts with, yes, iron 3 chloride, it's just that I'm a bit, yes, iron 3 chloride, the chemical formula of iron 3 chloride is just F, like this, plus hydrogen sulfide. What are you going to form? You shall form iron 2 chloride plus sulfur plus HCl. So, as you can see in this equation, it's somehow invisible, but you can just use your eyes well. From this equation, here is what I'm basing on. This hydrogen sulfide, its reducing property. Here it has reduced this iron 3 chloride to iron 2 chloride. Such like equation, the key point to take note there is the color. You should know the color of iron 3 chloride. Maybe when you take a gas, this gas hydrogen sulfide, or let's say gas X, is dipped into a solution. Maybe let's say iron 3 chloride, iron 3 chloride, which is yellow. Hydrogen sulfide, when dipped in a yellow solution of iron 3 chloride, it is going to form a green solution of iron 2 chloride. So that's how it has reduced iron 3 to iron 2. That is its reducing property. As I just told you in my previous lessons, this one is well explained in electrochemistry, whereby you are going to calculate the oxidation number and you see how that gas has reduced iron 2 chloride. Then number 2, and if you want to know more about that, you can do more questions that are concerning that reducing property. So the reaction with oxygen. So this hydrogen sulfide burns in air with the pale blue flame. In limited supply of air, it forms sulfur and water. So hydrogen sulfide reaction with oxygen. Reaction with oxygen. We have hydrogen sulfide reacts with oxygen to form sulfur and water. Hydrogen sulfide reacts with oxygen to form, water plus sulfur. That is reaction with oxygen. Then next, reaction with water. It reacts with water to form a weak acidic solution. Hydrogen sulfide reacts with water to form a weak acidic solution. Reaction with water. It reacts with water to form a weak acidic solution. Then we have reaction with aqueous metallic ion. Reaction with aqueous metallic ion. And that's where I'm going to stop from. Reaction with aqueous metallic ion. reaction with metallic ion. So in reaction with aqueous metallic ion you have like copper 2 ion, zinc ion, lead ion, and iron 2 ion. Those are example of aqueous metallic ion. So when, let me just write one equation. More equations you can get them in Wakelbi book 3. Copper 2 ion plus that gas plus from hydrogen sulfide, the ion that is going to react with copper 2 ion is the sulfur ion, which is S2 minus S. I have a power there. I have copper sulfate, Ks, the Cus. So copper ion plus sulfide ion is going to form copper 2 sulfide. So hydrogen, the reason as to why this copper ion cannot react with the hydrogen ion in the hydrogen sulfide is because the hydrogen ion contains a positive charge, and copper ion it also contains a positive ion, so the two cannot react. That's why the sulfide ion that has a negative ion reacts with the copper ion with the positive ion to form copper sulfide. So let's finish by looking at the test for hydrogen sulfide. How is this gas tested? Let's look how the gas is tested. How the test for hydrogen sulfide. The first test, have physical test, then the chemical test. So for physical test, this gas has a smell, an odor smell of rotten eggs. When the gas maybe is placed at the corner of a room or in a class, you will feel that smell of rotten egg. Test for hydrogen sulfide. The test. So a chemical test. The most question asked here is just the chemical test. Now let's look at the chemical test. The chemical test involves the reaction of a sample of a gas with lead acetate. You react the gas with lead acetate or lead 2 nitrate solution. The gas, maybe you can be asked to describe how hydrogen sulfide is tested in the laboratory. So we react the gas with lead nitrate. Let's use lead 2 nitrate. Lead nitrate, but I've just said you can use lead 2 nitrate, lead acetate, or lead ethanoate. So in the case we are using, in this case we are using lead 2 nitrate solution. Then a filter paper dipped into this solution forms a shiny brownish black solid of lead 2 sulfide. When you react lead 2 nitrate with hydrogen sulfide, then you take your filter paper and you dip it into the solution that you have obtained. When you are dipping the solution, this is what you are going to observe. You will see a shiny brownish black solid of lead 2 sulfide. That shiny brownish black solid is lead 2 sulfide. Now from this chemical test, you need to be very keen, because we have just a tricky question from that point. Maybe you can be asked a question from that point and it may contain 3 marks. So you should be very careful as I'm explaining. Then if the gas, when the gas is hydrogen sulfide, that's when you are going to form that you are going to see that observation that I've talked about. So from the test, you can be asked to write an ionic equation showing how the hydrogen sulfide gas is tested. This is how, let me show you a simple ionic equation to show how this gas is tested to form lead sulfide. This is a simple ionic equation showing how hydrogen sulfide gas is tested in the laboratory. This aqueous solid, that is the lead 2 sulfide I'm talking about. Then let's now finish pollution of air by atmosphere by compounds of sulfur. Here this something that is important here is the gaseous compound polluted by sulfur. When sulfur reacts, it mixes with air, it forms acidic rain. The acidic rain destroys plants, buildings, and etc. and is regulated by maybe those chimneys in the industries, the chimneys that are producing sulfur. The chimneys should be coated. Inside the chimneys, you should coat them with a substance that when the substance, let me just tell you what I'm talking about, the scrubbing process. The scrubbing process, this whereby the chimney that is producing sulfur, it is coated inside or lined inside with calcium hydroxide. And the calcium hydroxide, it is lined inside the chimney that contains the chimney that is producing sulfur. It is coated inside with calcium hydroxide, and the calcium hydroxide reacts with sulfur oxide by a process known as scrubbing process. Lastly, you should know about the FGD, flue gas desulfurization device. That's another method for preventing the pollution of air by sulfur. And that marks the end of this topic, sulfur and its compound. Thank you for listening, and subscribe to our channel so as each and every time we shall be uploading a video, you can get in touch with it. Thank you.